In this example, there is a rubber band shown by this green line over here, and it is stretched from an unstretched position AC. So this is the unstretched position AC, and it has been stretched to B to C. As a result, it will have a force F in it. So it is asking, the question is asking, how much moment, or what is the value of the moment about point O. So point O is in the shoulder area here. So we have to find the moment of that force about point O. So first thing is to calculate what is the force. Now the force in the elastic band would be proportional to its elongation, and proportionality constant is given by this elastic modulus, which is 60 Newton per meter. So first thing, we need to find out the value of force F, and to get that value of force F, we need to find out how much this elastic band has been extended from its unstretched position AC to BC. So the length AC is given as 740. AC is the unstretched length. The stretched length is B to C, and we have to find out what is B to C. Now to calculate B to C, what we can do is we can consider this triangle here. So for this triangle, we can write the BC square would be equal to OB square plus OC square. Now what is the value of OC? Now value of OC would be OA plus AC. So OC would be OA plus AC, which is equal to, now OA is same as OB because it's the length of the hand. So OB plus AC. Now how much is OB? Is 635 millimeter plus AC is given at 740 millimeter. So OC would be 1375 millimeter. So that gives us BC now. So BC would be, using Pythagoras, we can get OB square, which is 635 square plus 1375 square. So that would give us 1515 millimeter. So how much is the extension or the elongation of the band? So the elongations, if you write, so elongation of the band, if we call delta, that would be BC minus its original length AC, which will give us 775 millimeter. Force F would be proportional to this elongation, but that would be multiplied by this elastic modulus 60 Newton per meter. So F would be that K times delta. Now K is the elastic modulus 60 Newton per meter. So we have to convert this 775 to meter. So that would be 0.775, that much of Newton. So that would give us 46.5 Newton. Now to calculate the moment about point O, what we can do is we can drop a perpendicular line from point O to this line of action of the force and measure this distance d and multiply with F times d. That would be surely one way to do. But an easier approach would be to resolve that force F in the horizontal and vertical direction. So we can resolve this force in the horizontal and vertical directions. To resolve this force, we need to calculate the angle or one of these angles. Let's say this angle is theta. So by using this triangle, right angle triangle, tan theta would be equal to OC by OB. So which gives us theta will be equal to 65.2 degree. So if this force is F, the component in the horizontal directions would be F cosine theta. And the component in the vertical directions, this component would be F sine theta. So for F sine theta component, we will get the moment about point O. There will be no moment due to F cosine theta because that force passes through point O. So the lever arm would be 0. So to calculate the moment, what we need to multiply is F sine theta times the distance. So the moment that we are interested in, M, is equal to F sine theta times the distance OB. So if you do all of these together, you will get an answer as 26.8 Newton meter, and it will act in the anti-clockwise direction. So the directions of the moment would be anti-clockwise. Okay, so this completes this tutorial. So before I complete this example, do note that for the moment here the unit is Newton meter. So for moment always you will have one force unit and one length unit. We have used for force unit Newton and length unit meter. So here we have got Newton meter.